All right, guys. Hey, it is what is it? Tuesday. Holy cow, it's Tuesday. So a couple things. Number one, hopefully you were able to use the catch-up day we had yesterday to get caught up. I didn't hear from many of you. A few of you did reach out, and so I was able to connect with a few of you. I'm hoping you just needed the time. Okay, so hopefully you had that. The other thing, just remember today is Tuesday. So today at 10 a.m. we have chemistry live. We're going to do the second part of our Kool-Aid lab. We did the first part last week, and now the second part we'll do today live. So page 2 we'll do today live. Then you can turn it in, and you're done with that lab. So we'll see you today at 10 a.m. If not, no worries. You got another shot Thursday at 1. Okay. So here's what I want to do today. I'm not going to teach you anything new, nothing new. We are going to talk about molarity. And I don't know if you remember, but the last time we talked, I like the rock and roll quotes rather than these. This is like rock and roll cool. This is like nerdy science teacher. So rock and roll. We talked via computer, via video. The last time we talked about that molarity triangle, right? So we're going to use that again today. Nothing new. The issue is that works, that molarity triangle works as long as you have moles, liters, and molarity. Today, I'm not going to give you moles, okay? Today, I'm going to give you something else. I'm going to give you grams. And now, in order for you to do this, you're going to have to be able to convert from grams to moles. Now, we've done that. For most of you, that was last trimester. For some of you, that was maybe last year. So remember, to go from grams to moles, you have to figure out the molar mass, which actually is pretty easy. You can do that, but that's a step we'll have to do, and I'll show you how to do that in a second. So if you opened up the worksheet posted on Google Classroom, there's dig it, 4 questions in the worksheet. I'm going to go through all 4 of them, okay? I go through, I write it down, you write it down, click turn it in, you're done. Now, if it doesn't work, and I had a couple of you reach out and you did it and you filled it out and you turned it in, but then you reached out and said, okay, I did it. I didn't really get it. I wasn't really following. It didn't make sense. That's probably my fault. That's probably me not having clarity. So if that's you, please reach out. Please let me know, and then we can remediate that. We can make sure you get it. I'll try again. Maybe we can share screens. Maybe we can do email. Maybe we can do whatever. I'll figure out a way to make sure you can do this. Okay? So 4 questions. The first one is nothing new. The first one is what we did last week. Okay? So look what I have. Oh, it's going to not work. Okay. Sorry, guys. The first one is, oh no, try it again. Come on now. First one is moles and liters, all right? And it asks for molarity. And remember, molarity is capital M. So look at the molarity triangle, right? There's 3 things: molarity, capital M, moles, and liters. So if you have those 3 things, all you have to do is use the triangle. So remember how we did that. We said if you're trying to solve for molarity, which is what we're solving for here, all I have to do is cross that out on the triangle, make it disappear. And then look at, what do I have left? Well, I have moles on top of liters. So the equation we use is molarity equals moles on top of liters. Done. That's my equation. And then I just plug it in. I go, all right, 1 mole on top. And then I'm going to go 0.10 liters on bottom. Right? And I pull out my handy calculator. I type that in. If you do that, you find molarity equals 10. 1 divided by 0.1 is 10. So 10 molar, that's your answer to number 1. Boom. We're a quarter of the way done. Okay, now that wasn't anything new. That's what we did last week. Solving for molarity. And again, molarity is a measurement of concentration. How concentrated it is. If it's more than 1, it's concentrated. If it's less than 1, it's dilute. So this is 10. This is a very concentrated solution. Okay, 10 molar is a concentrated solution. That's it. Okay, so 1 done. Let's look at number 2. Here we go. I have 1 gram of potassium fluoride, which is dissolved to make 0.1 liters of solution. So if you look back to the last question, the volume of solution hasn't changed. We're still trying to determine molarity, which is capital M. So nothing has changed. Here's what's changed. Instead of moles, I now have grams. So now look at my hint. It says, in order to determine molarity, capital M, you must first convert grams to moles. Because I need to use this triangle, right? I don't have grams, I have moles. So how do I get moles when all I have is grams? Okay, well, let me help you out. First of all, you got to use your faithful, handy periodic table. And you got to say, all right, what do I have? Well, we have potassium fluoride. Now, that is KF. And so I got to find them over here. I have K right here. That's a metal. And I have F right here. That's a non-metal. But if I look at the very bottom, and I know it's so small in this PowerPoint, at the very bottom, there's the atomic mass of each one of those. And if I take K and I take F and I take and look, well, how many do I have up here? Well, I have 1 K and I have 1 F. So if I take one of these massed up, which is, my eyes are so bad, I don't know if I can zoom. I can. Cool. Look at that. It says 30, I'm going to round it to 39.9. Okay, I take one of those. Ooh, now it's not going to work to write on the right. What did I say it was? 30. See, I'm old and forgetting stuff. 39.1? I think that's 39. Ha! I'm old. 39.1. And then I have 1 F, right? If I look over at F, it's 18.99. Okay, we're going to just call that 19. That's close enough. 19. So if I take 39.9 and I add that to 19, I get what's called the molar mass. Well, what is that? It's 58.1. Okay, 58.1. Now the units that comes in is grams per mole. That's my molar mass. Okay, well, that's it then? Do I plug that in here? No. That's grams per mole. I got to get just moles. It's still in grams. Crud, how do I do that? Well, remember the conversions. So what do I got? I got 58.1 grams. I want to get rid of grams. So if it's on top over here, I have moles on bottom. Okay, if it's on top over here, how do I get rid of grams? I got to put it down here. And what do I have? Well, what? That doesn't make sense. I don't get it. Okay, let's start a different way. Let me start over because that I confused myself even on that. Okay, we're going to use that still. See, I'm not always making sense of what we got. Let's go back to what we got, right? I have 1.0 grams. I don't want grams, I want moles. So what do? I got to get rid of grams. Grams is on top right there. So to get rid of it, to cancel it out, grams has to go on the bottom. What goes on top is moles. Okay. So this is a conversion factor. Sorry, I want to make sure I use the right words here. This is a conversion factor. When it says 58.1 grams per mole, that means 58.1 grams is equal to 1 mole. So I can go 1 mole is equal to 58.1. Okay, then I take out my calculator. I go 1 times 1, 1 times 1 divided by 58.1. When I did that, I typed it up. I got 0.017. Now remember, grams on top, grams on bottom. All that's left is moles. I got 0.017. Now I go back to my molarity triangle. I want to solve for molarity, right? So molarity equals moles, which I just found out, over liters. Liters is right here, 0.1 liters. Pull out my calculator, 0.017 divided by 0.1. I get 0.117 molar. That's my answer. Oh, that's a lot. Okay, so you had to figure out the molar mass and then take that number, that mass, convert it to moles, and then take the moles, put it over liters, and then you can solve for molarity. I know that's a lot. Let's do another one. Here we go. Number 3. Again, same issue. Trying to solve for molarity, but I don't have moles. I have grams. Liters, I'm good, right? But I don't have moles. I got to figure out, well, how many moles do I have? I have 1 gram, but how many moles? So again, I got to find out, well, what do I have? I have sodium chloride. So here we go, right? Oops. Try that again. I don't know if it'll let me. Okay. I look over here, here's sodium. I look over here, here's chlorine. Okay, well, what do I have? I have 1 sodium, I have 1 chlorine. I'm going to take that, I'm going to take that, and I'm going to add them together. Right? Sodium is about 23, chlorine is 35.45. I add those together, here's what I get. Now, what does that mean again? That means 1 mole of sodium chloride is equal to 58.45 grams. That's my conversion factor. That's what I need to make a fraction in order to convert grams into moles, huh? Let's do it. So what do I have? I have 1.0 grams. I don't want grams, I want moles. So I'm going to multiply by a fraction. Grams are on top here. Grams need to go on the bottom over there in order to cancel out. I have moles on top here. Well, 1 mole, right? 1 mole is equal to how many grams? 58.45. All right, now we go grams on top, grams on bottom. They cancel. Now I pull up my calculator. 1 times 1 divided by 58.45. When I do that, I get 0.017 moles. Now I got it. Now I got it. That's this, right? I'm still trying to solve for molarity. So I still want to go moles over liters. I now have moles. So I can go, all right, here we go. 0.017 moles over how many liters? There it is at the top. It's a little tiny amount, 0.001 liters. Pull up my calculator. I dial it up. When I do that, I got 17.1. And again, that's capital M. Whoop. That's capital M, which is molarity. So I know that's a lot, right? To go from grams to moles, you first got to get molar mass. Then you do your conversion, figure out your moles, then go moles over liters, and you get molarity. Let's do one more. Okay, one more. Same issue. I want to solve for molarity. I need moles over liters. I have liters. I don't have moles. Crud. How do I get moles? Again, I got to find on the periodic table. Now, look at what I got. I have barium carbonate. This one's a little tougher, but not really, right? What do I have? I have barium. That's this guy right there. And I have carbonate. Well, carbonate is made of carbon and oxygen. But now look at it. I have one barium. Look at it. I got one carbon. Over here, that little 3 down there tells me I have 3 oxygens. So how do I add this up? Well, I take one barium, I add that to one carbon, and I add that to 3 oxygens. So yes, I got to look here. Oops, sorry. I got to look here. Let me do it. Oops. I got to look here at the bottom, right? How much barium? How much does that weigh? Carbon, what does that weigh? 3 oxygens, what does that weigh? I add it all up. When I did that, and I'm not going to do it on the screen for you, when I did that, I got this 197.3. Now, what does that mean? That means 1 mole of barium carbonate is equal to 197.3 grams. Okay? Well, okay, that's 1 mole. How much is 952 grams? Again, here we go, same thing. 952 grams. I don't want grams, I want moles. So grams is on top here. To cancel, it has to go on bottom. That is 197.3. And on top, I need moles. That's 1. Grams on top, grams on bottom. I pull up my calculator. I go 952 times 1 divided by 197.3. When I did that, I got 4.82 moles. Now I got it, right? That's how many moles. So now I just plug it in. Molarity is moles over liters. What's moles? Moles were 4.82. What's liters? There it is in the question, 1.75. Pull out the calculator, 4.82 divided by 1.75. I got 2.76, and the units is molarity. 2.76 molar. That's it. So it's really nothing new. I'm not saying it's easy, but I'm just doing my molarity triangle, but I have to convert grams over to moles. Okay, that's a lot. We did 4. Okay, write down what I wrote down, turn it in, submit it. We'll keep practicing, we'll keep working. Don't quit. You can do this. I know it's hard, but you can do it. You guys are so smart. You work so hard. Keep plugging. I'm proud of you. That's it. Turn it in. Make sure you turn it in. Even if you didn't do all of it, turn in what you did. If you're stuck, text me. Call my office number, my Google voice number. Okay, let's hang out. Remember today, 10 a.m. we have Chemistry Live. We'll do some more of this today in Chemistry Live. Okay. Hey, that's it. Good job. You survived it. Way to go. We'll see you on the flip side.